We tend to think of cosmic dust as something distant and abstract, something we see in beautiful photographs from space telescopes showing distant nebulae and cosmic wonders. But here's the shocking truth that most people don't realize. Cosmic dust is far closer than you think. It's literally all around you right now. It falls from the sky in a continuous stream, and particles are settling on the streets of your city, on the roofs of your buildings, possibly even on your clothes as we speak. But before we dive deeper into this absolutely fascinating topic, I want to ask you something really important. If you're watching this video right now, please smash that like button, comment below, and tell us where you are watching from around the world. Are you in a big city or somewhere remote? Tell us your location so we understand who our audience is and where hope is being watched from across this planet. And if you haven't already, please subscribe to our channel because your support truly means everything to us. Now let's explore the cosmic dust that's literally raining down on our world right now. So here's the big question. How much cosmic dust actually travels through interplanetary space and reaches our world? What does this dust tell us about our solar system, about Earth itself, and what role might it have played in the emergence of life on this planet? These are the profound questions we're exploring today, and the answers might surprise you. If you've ever been far from city lights, just after sunset or before sunrise, you might have noticed a faint glow stretching upward from the horizon. This glow isn't particularly bright, and honestly, I'm not sure many of you have actually seen it before. But if you have, you've witnessed something extraordinary called the zodiacal light. It appears widest at the horizon in the direction of the sun and gradually narrows as you raise your gaze higher into the sky. But here's the thing that blows most people's minds when they learn it. This isn't something flying in our atmosphere at all. It's countless tiny dust particles, literally billions upon billions of them, drifting through the space between planets. These particles scatter sunlight in an ethereal band stretching across the sky. Because this band passes through the zodiacal constellations, it earned its name. In reality, this line demonstrates a dust disk that traces the ecliptic plane, which is the plane of our solar system, where dust concentration is greater than elsewhere. So here's one way to actually see the disk of our solar system with your own eyes. To look at its dust. Of course, Earth rotates within this environment, so naturally cosmic dust reaches us continuously. Throughout Earth's multi-billion-year history, extraterrestrial material has been falling continuously, and this stream never stops, never pauses, not for a single moment. We're most impressed by chunks of metal and stone that, after their fiery descent through the atmosphere, eventually land on Earth as meteorites. All these meteorites vary greatly in size and can be just a few millimeters across. But here's the secret that most people don't know. Most cosmic material falling to Earth is far smaller than meteorites. We're talking about submicrometer particles, particles so small they're almost impossible to see with the naked eye. Historically, it was extremely difficult to calculate how many microparticles from space actually settle on our planet each day. The main problem: dust that Earth itself produces. All the pollution, all the dust from cars and factories and deserts, it all contaminates the measurements. So it's no wonder that estimates of cosmic dust influx varied wildly, from a few hundred kilograms to several hundred tons per day, depending on the measurement method used. One approach that scientists developed involves not searching for dust already fallen, but counting particles during their actual descent through the atmosphere. The primary sources of dust in our solar system, according to astronomers, are asteroid collisions and material released from comets traveling too close to the sun. When these particles approach our planet, they strike the atmosphere at various speeds, anywhere from 11 to 73 kilometers per second, depending on their orbital direction relative to Earth. That's incredibly fast, fast enough to heat particles to over 1600 degrees Celsius through friction with air molecules. This causes some material to melt and create shooting stars in the sky if particles exceed 2 millimeters in diameter. The dust that completely melts releases certain chemical elements into our atmosphere, particularly sodium and iron vapors. These vapors recondense into nanoparticle-sized particles, forming what scientists call meteoric smoke. Scientists learn to detect this smoke using various methods, including sensitive radar observations and high-altitude aircraft flying in the lower stratosphere. Through these observations, they calculated that between 400 kilograms and 40 tons of cosmic dust enter Earth's atmosphere daily, or approximately 5 tons on average. That's enough that cosmic particles are literally right now lying on your roof, settling on your streets, existing all around you. It's crucial to understand that this constant presence of cosmic material significantly affects our atmosphere's chemistry. For example, cosmic dust relates to a special atmospheric phenomenon that astrophotographers absolutely love capturing on summer evenings: noctilucent clouds. These are ice crystals accumulating on meteoric smoke particles, which serve as a framework for ice crystal growth. These clouds appear strikingly beautiful and notably bright because they form in the upper atmosphere, essentially at the edge of space, typically around 80 to 85 kilometers altitude. They hover so high that sunlight still illuminates them even after the sun sets beyond our horizon. That's why noctilucent clouds are so brilliant and distinct. Interestingly, our planet isn't unique in this regard. The Curiosity rover captured images of these clouds in the Martian sky in 2019 and 2021. Cosmic dust doesn't settle only on our planet. Scientists believe cosmic dust's atmospheric impact extends much further than we initially thought. There's a hypothesis that meteoric smoke and fine cosmic particles can interact with clouds that play a crucial role in ozone layer destruction in the stratosphere. They might be involved in forming the famous Antarctic ozone hole, though these effects are still being studied intensively. Additionally, we can't ignore cosmic dust when considering potential climate change solutions. You might have heard about the idea of combating global warming by dispersing sulfate aerosols into the atmosphere. The concept is that they can reflect some solar energy back to space, protecting our planet from overheating. However, implementing this requires understanding cosmic dust and meteoric smoke, and comprehending what chemical reactions might occur with their participation. Tiny asteroid and comet fragments are integral to our atmosphere, and their role in atmospheric chemistry remains under active investigation. Scientist Matthew Genge studied cosmic dust for 30 years. During an Antarctic meteorite hunting mission, he collected 6 grams of material and isolated over 3,000 space fragments by identifying spherules, tiny spherical particles evidencing atmospheric passage. Using magnets and electron microscopes confirming cosmic origin through isotope ratios, he demonstrated Antarctic collection effectiveness. NASA maintains over 11,000 particles, many from Antarctica. Antarctica is ideal for dust collection because ice covers it year-round with complete isolation from other continents, minimizing contamination. New snow continuously covers settling dust, allowing scientists to determine deposit age and influx dynamics. In 2021, after 20 years of research, scientists excavated ice near the Concordia station and isolated over 2,000 particles. Small, lightweight particles don't melt during atmospheric travel. Comet dust looks fluffy and irregular. Over 60% came from Jupiter family comets, 20% from the asteroid belt. Researchers determined that between 4,000 and 7,000 metric tons of cosmic dust settle annually on Earth. Accounting for atmospheric burning, annual influx reaches approximately 15,000 tons. This makes cosmic dust the primary extraterrestrial material source, exceeding meteorites by hundreds of times. Every square meter receives approximately 10 particles annually. Everywhere. Streets, homes, cars, clothes. Mercury's orbit should have minimal dust, yet Stereo spacecraft discovered a 5% denser dust band encircling it in 2018. Venus has a larger, brighter ring, confirmed by Parker Solar Probe imagery. When Juno traveled toward Jupiter, it accidentally became a cosmic dust detector. Particles struck solar panels, revealing dust concentration. Juno's trajectory mapped dust distribution, discovering Earth's dust cloud extends to Mars's orbit, originating from asteroids and comets. The Rosetta spacecraft confirmed this. Most micrometer particles spiral toward the Sun through the Poynting-Robertson effect, encountering planets that absorb dust like vacuum cleaners. Large meteorites wander the solar system for millions of years before reaching Earth, making influx random. Dust particles, being numerous and constantly arriving, better reveal solar system activity. The universe shares its secrets through cosmic dust. Billions of particles reminding us we're part of something far greater than ourselves.